your name is enough to include your registration number as your name. So please rename your name with your registration number. Okay, we need to get the attendance. So please include your registration number as your name. Okay. So I think you can hear me. We can start the lecture at 10:30. So please rename your name with your registration number. Yet I can't see some of your registration numbers, so I need to get the attendance. So please include your registration number. Janitya, please include your registration number first. No need to include your name. So please include your registration number first. Yeah. Jairatna AWMR, please include your registration number. Gagana, please include your registration number first. No need your name. We have to get your attendance, so please include your registration numbers. Okay. Tarindu Deshan, please include your registration number first.
Recording in progress.
Okay, we can start the lecture. Please, anyone tell me, can you hear me and can see my screen clearly?
Yes, madam.
Okay. Okay, last week we talk about the linear Diophantine equation in two variables. Now I will give a brief introduction again for the linear Diophantine equation in two variables. You know that how to represent linear Diophantine equation. For that we consider three integers a, b, c, and ax plus by equals c, and using the linear Diophantine equation we are going to find the solution for x and y variables, and we should get integer values as the solution for x and y. Okay, and uh, we studied this theorem to find the solution for the linear Diophantine equation. The linear Diophantine equation is ax plus by equals c. This equation has a solution if and only if the greatest common divisor of a and b divide c. Okay, d is the greatest common divisor of AB. Here we consider this linear Diophantine equation has a solution if D divides C. Then D divides C, we can say this linear Diophantine equation has a solution. We can consider the revised process. The linear dipentane equation has a solution if D divides C. For the if and only if process, you can consider the linear dipentane equation has a solution if D divides C. We can consider the revised process. If D divides C, the linear dipentane equation has a solution. So you have to remember these formulas to write the general solution for the linear dipentane equation. Always to write the solution for X, we use this formula. X equal X naught plus B over D times T. Here we introduce a new variable T. For T, we should get an integer value. Okay. For Y, Y naught minus A over D times T. Here you should include minus. X naught and Y naught represent a particular solution of this equation. Okay. Using these two equations, you can write the general solution for this linear dipentane equation. And we consider two examples, I think, and I discussed this one, no? As I remember, I think I discussed the problem number 15, no? Is it correct? We got the answer x equal to y equal 11 and y equal 40 and y equal 70. No. Please tell me, anyone?
No, madam.
Now you can write this example problem. Problem number 15. You can write the question first. After that, you can find the solution. Okay. So please write down the problem. There are two types of stamps are available in a post office. First type cost 69 rupees per each, and the second type cost 27 rupees. A person bought two type of stamps for the total of 1218. Find how many of each type of stamp he could buy. First, you have to define your variables. Here you have to consider two variables. According to the linear dipentane equation, we consider variable as x and y. So first define what is x and y. X, the number of first type stamps. The second one, second type of stamps. You have, by using the given information, you have to construct a linear equation. Okay, linear dipentane equation. You have to write this linear dipentane equation. Okay. We consider x as the number of first stamp, y is the second type of stamp. Then we have the total price 1218. Then we can write 69x plus 27 times y equal 1208. 18, not 8, 18. We obtain the linear dipentane equation. According to the linear dipentane equation theorem, first you have to show this equation has a solution. Then you have to find first the greatest common divisor, D. A equals 69, B equal 27. Find the greatest common divisor. It is 3. 3. 3 divides C. You can see 3 divides 1218. Now, using that, you can say this linear Diophantine equation has a solution. Then you can apply the division algorithm to find the particular solution x naught, y naught. Okay. Please try to understand this problem. In the examination, you will see this type of problem. Okay. You will have to build up the linear Diophantine equation and find the greatest common divisor. And using the theorem, you should show this linear Diophantine equation has a solution. After that, you can find the particular solution x naught, y naught. And using the given two formulas for x and y, you can find the general solution. Using the positive integer values, you can find the value t. After that, you can find the solution for x and y. Always we should get integer values for x and y as the solution. Okay, you have to remember that. Here we consider the two variables for the linear Diophantine equation. Using the division algorithm, Euclidean algorithm, you can find x naught, y naught. I think you got this answer. X naught equal 812, y naught equal minus 2030. Then you can write the general solution using this formula. You have to identify what is b and d. D is the greatest common divisor. Here we include minus sign. You have to remember this one. Okay, according to the given two formulas, you can write the general solution. Here we consider plus, here minus. You have to remember that. Okay, so always we assume t as an integer value. Then now we are going to find the value of t. Since x and y are non-negative integers, then we need greater than value for x and y. X greater than or equals 0, y greater than or equals 0. Using that, you can find the value of t. According to this inequality, you can decide the value for t, simple t, minus 90 and minus 89. No, minus 90, no? T equal minus 90 and minus 89. We obtain two integer values. For t, we cannot consider the decimal numbers. Always we should consider the integer values. Then we can get, according to this inequality, we can get t equal minus 90 and minus 89. First substitute t equal 90. You can get two answers for x. No, one answer for x equal 2 and y equal 40. We obtain one solution for x and y. Next, consider t equal minus 89, x equal 11, and y equal 17. For this example, we obtain two solutions, x equal 2, y equal 40, x equal 11, y equal 17. Okay, then you have to write the answer. Therefore, the person could buy either two first type stamps and 40 second type stamps, or 11 first type stamps and 17 second type stamps. Okay. Please try to understand how got the solution. Okay. If you have any doubts regarding the problem number 15, now you can ask me. If you need, I can explain it again. Okay. Equation, what are the variables, what are the integers, how find t, and how use the theorems to find the solution. Okay. If you have any doubts regarding problem number 15, you can ask using chat box. Okay. After that, I can give the answer. I can clear your doubts. So please ask any questions regarding problem number 15. No. We can move to the problem number 16 now, no? Okay. Write down the problem number 16. The neighborhood theater charge 180 rupees for adult admission and 75 for children. On a particular evening, the total receipts were 9,000, assuming that more than uh, assuming that more adults than children were present. How many children attend? තියට් එකක් තියෙනවා. ඒක ඇඩල්ට් කෙනෙක්ට එක වැඩිහිටියෙක් කෙනෙක්ට charge එක 180යි. පොඩි children කෙනෙක්ට එක ස්ටුඩන්ට් එක පොඩි ළමයෙක්ට 75 charge කරනවා එක්කෙනෙක්ට per. අන්තිමටම calculate කරනකොට එයාලා earn කරලා තියෙනවා 9,000ක්. assume කරන්න කියනවා problem එකේ present ඒ කියන්නේ theatre එකට ආවේ වැඩිපුරම වැඩිහිටි කට්ටිය ළමයිට වඩා. එහෙනම් අපෙන් අහන්නේ how many children attend? කීයක් ස්ටුඩන්ට්ස්ලා කීයක් පොඩි අය ආවද කියලා තමයි හොයන්න ඕනේ. Then we have to identify the variables. By considering this problem, we should consider the linear Diophantine equation according to this problem. Then first you have to identify the variable. According to the linear Diophantine equation in two variables, we consider the variables as x and y. Then first you should define x and y. Okay. X is the number of adults attend, y is the number of children attend. Then you can write the linear Diophantine equation 180 times x plus 75 times y equal 9,000. Okay. First find the greatest common divisor and check whether this linear Diophantine equation has a solution. If not, you can proceed. You cannot find the other particular solution. Okay. According to this example, a linear Diophantine equation has a solution. So you can write it first. After that, you can find the particular solution and find the t value, value, and find the general solution and find the final answer. Okay. So I will give 10 minutes to find it, and you all should write your answer using chat box. Okay. You all should give the answer. Okay. For this problem. I will give 10 minutes to write the answer. Okay. Please include your GCD, greatest common divisor, and find the particular solution, find T, and find general solution. Okay, you have to include your GCD value, T value, particular solution, and solution. Okay, using chat box, you should include your answers for the greatest common divisor, the second one T, no, second one particular solution, third one T, the last one final answer. Okay. Did you get the answer? What is GCD? Please include your answers into your chat box. I need to check your answers, so please include your answers into the chat box, okay? Yes, GCD is 50, no? So next find the particular solution. GCD is 15. Then the linear Diophantine equation has a solution. 15 divides 9,000. Then the linear Diophantine equation has solution. Then we can find particular solution x naught, y naught. What is your x naught and y naught? Yes, for x naught you can get minus I will show the answer. X naught equal minus 1,200, no? Y naught equal 3,000. Then we found the particular solution using the given two formulas. You can write the general solution, no? So this one, you can get these two equations. Now you should find the value of t. You can get three values for t, no? T equal 248, 249, 50, 250. Then you can get three solutions for x, y. The problem asks about the number of children attending for the theaters. So you should write the final answer as y equal 24 or 12 or 0. Okay. Please rename your name with your registration number. We need to get your attendance, okay? So you have to rename your name with your registration number, okay? Okay, we can move to the next topic. Linear Diophantine equation in 3 variables. Now you can write this note. In the linear Diophantine equation in 3 variables, we consider x, y, z. In 2 variables, we consider only x, y. The linear Diophantine equation in 3 variables, we considered x, y, z. Additionally, we include c, z to the linear Diophantine equation in 2 variables. Okay, so here we consider ax plus by plus cz equal n. Again, we assume a, b, c and n are integers. And by solving this equation, we should find the integer values x, y, z. For x, y, z as integer values, we should find the solution. Okay. So you can write this note. Let the given equation be x plus by plus c z equal n. Give the name for this equation 1, where a, b, c, n are integers. We need to find all the triples of integers x, y, z that satisfy this equation. Now we are going to find the solution. Then we write ax plus by equal n minus cz. We convert this equation to the linear Diophantine equation in 2 variables. And here we fix the value of z by introducing another variable t, another value t. Now we consider here z is a constant value t. Okay. So using the previous theorem for the linear Diophantine equation in 2 variables, we know that the greatest common divisor of AB divides n minus Cz. In the linear Diophantine equation in 2 variables, we said that the linear Diophantine equation has solution the greatest common divisor if greatest common divisor divides C. So we consider this one as M. If M, the greatest common divisor of AB divides M, we can say this equation has a solution. Okay. So we write uh, the equation 2 has solutions if and only if the greatest common divisor of AB divides this one n minus Cz. Here we include Z as a t value, fixed value. Okay. So we can write it. The greatest common divisor of AB divides n minus Ct. Using this one, using the divisibility theory, you can write n minus Ct equal k times d. Okay. And d is the greatest common divisor of AB. Using this one, you can write kd plus ct equal n. We give the name 3, equation 3. According to this linear Diophantine equation in 2 variables, again we can write this solution, this linear dipentane equation has solution if and only if the greatest common divisor of DC divides N. This one. It means the greatest common divisor of A, B, C divides N. Okay. Then using this one, we can say the linear dipentane equation in 3 variables has solution if and only if the greatest common divisor of A, B, C divides N. Okay. Did you understand that? අපි මෙතන කරේ මුලින්ම අපි ඉගෙන ගත්ත linear dipentane equation in two variables. එතන කිව්වා ඒ equation එකට solution එක තියෙන්නේ greatest common divisor of AB divides C now. According to this example, we consider three variables ax plus by plus cz equal n. Then we have to find this, three solutions for three variables x, y, z. Then we convert this one to two variables linear dipentane equation by considering z as a fixed value t. Okay, so we write ax plus by equal n minus ct. For z we substitute t. Okay, and then this one is a constant value. N minus ct is a constant. We can take it as a c or z. Then we can consider this one as a linear dipentane equation in two variables. In two variables, we know that that equation has a solution. The greatest common divisor of AB divides this value. No. According to that, we can write the greatest common divisor of AB divides this one, n minus ct. By considering this one using the divisibility theory, let's say if we need to write A divides B. In the first lecture, I explained this one. A divides B, represent B. B is a multiple of A, then B is a factor of A. Then we can write B equal K times A, no? Is it correct? This one. If A and B are integers such that A not equal 0, we divides A divides B. Then we can write B is a multiple of A. B equal K times A. Okay. A is a factor of B and B is a multiple of A. Okay. Using this definition, we can write n minus ct equal K times D. D represent the greatest common divisor of AB. Okay. Then we can write KD plus CT equal N. Greatest common divisor of DC divides N. Okay. If this satisfy this one, we can say the equation 3 has a solution. Okay, and we assume D as the greatest common device of AB. Here we represent using the open bracket the greatest common device of DC. Then we can write for D again GCD of AB. AB. And in open bracket, we consider GCD, then we can write GCD of ABC divides N. Then we can say the equation 1 has solution if and only if the greatest common device of these variables A, B, C divides N. Okay. Okay, now let's see the problem. We solve the linear Diophantine equation in three variables 30x plus 12y plus 9z equal 3. Okay, find it. For the examination, I will give the linear Diophantine equation in two variables. Okay. For the in-class assignments, I will give, sometimes I can give the three variables linear Diophantine equation. I will give a hint later, okay? So now you can write this one. First, we need to check the uh, greatest common device of A, B, C. It is 3, 3 divide 3. Then the linear Diophantine equation in three variable has a solution. Okay, today we can start the next chapter. I think the chapter 3. In chapter 3, you can learn theory of congruence, chapter 4, limits and continuity, chapter 5, differentiations, and chapter 6, groups theory. Today we have complete 5 lectures, no? By considering x, y, z greater than 0, you can find the value for t1, t2, okay? So you can do it as a homework. We can start now the chapter 3, okay? Okay, write down the topic theory of congruence, chapter 3, theory of congruence. Okay, you can write the definition. Let simple n be a fixed integer. Two integers a and b are said to be congruent modulo n. We can write it as a congruence b under modulo n. Using the divisibility theory, we can write this one as n divides a minus b. Here, using the open bracket, we write only open bracket. No need to consider the greatest common divisor for this one. Okay. A divides a minus b. So that is the reason to consider always GCD to represent the greatest common divisor. Using this open bracket, we didn't consider always to represent the GCD. මේ මෙතන යූස් කරලා තියෙන open bracket එකකින් කියවෙන්නේ නැහැ අපි consider කරන්නේ GCD කියලා. That is the reason to consider always to represent the notation for the greatest common divisor we use GCD. Okay. ඒකයි ඉස්සෙල්ලා තියෙන chapter එකේ chapter 2 වලදී greatest common device එක හොයන්න open bracket එක විතරක් use කරේ නැත්තේ මම. නැත්නම් ඔයාලා පටල ගන්නවා. මෙතන a, b කියන එක use කරේ නෑ මා. හැබැයි සමහර පොත්වල තියෙන්නේ මෙහෙම. ඔයාලා පටල ගන්න නිසා මම greatest common device එක use කරන්න always use කරේ GCD open bracket. හරිද? මෙතන කියන්නේ GCD කියලා. misunderstand කරගන්න එපා. A modulo A congruence B under modulo n. Using this one, we can write n divides A minus B. And we can write it another way using the divisibility theory. A minus B equal K times n. Using that, we can write A congruent B under modulo n. Okay. Okay, consider this example 3 congruent 24 under modulo 7. Consider here A as 3, B as 24. What is in 7? Then identify the value of K. What is the value of K? Here K. K times 7. Huh? What is the value of K? K always represent an integer. It can be a positive or negative value. Then what is the value of K? Minus 3, no? Minus 3 times 7 minus 21. Minus 21 plus 24, you can get 3. It is 3 congruent to 24 under modulo 7. Did you understand the meaning of this one? මේකෙන් කියන්නේ නෑ කොයිවෙම වෙලාවෙවත් 3 සමානයි 24 කියලා. තේරුණාද? අපි consider කරන්නේ 7 ගේ multiplications එක්ක. ඒ කියන්නේ 3 කියන කෙනා 3 24 7 මල්ටිෆිකේෂන් එකක් ඇඩ් කරලා හරි 7 මල්ටිෆිකේෂන් එකක් අඩු කරලා හරි 3 කියන එක ගන්න පුළුවන්. 3 congruent 24 under modulo 7 කියන එක තමයි represent කරන්නේ. To represent A incongruent B under modulo n, we can write this notation. Using this one, we can say A incongruent B under modulo n. Here I have mentioned that the example 3 incongruent 8 under modulo 6. 3 කියන කෙනාව 8ට 6ක් එකතු කරලවත් 6ක් අඩු කරලවත් ගන්න බෑ. ඒ නිසා අපි කියනවා 3 incongruent 8 under modulo 6. Okay. Okay, you can write this note. Given an integer A, here I have mentioned that the division algorithm, Q and R be the quotient and remainder upon division by n, so that we can write A equal Qn plus R. Q is the quotient and R is the remainder. Always R represent the values from 0 to n. Okay. We learned this one using in the division algorithm divisibility theory. In the divisibility theory, we obtain this one. Okay. According to this one, you can see again we represent it like this. No, A equal Qn plus R. Using this one, you can write the congruent A congruent R under modulo n. Okay. Since there are n choices for R, 0 to n, we see that every integer is congruent modulo n to exactly one of the values 0, 1, 2 up to n minus 1. In particular, A congruent 0 under modulo n. N divides if and only if n divides E. The set of n integers 0, 1 up to n minus 1 is called the set of least positive residues under modulo n. In general, the collection of integers a1, a2 up to n is the set to form complete set of residue modulo n. If every integer is congruent modulo n to one and only one of ak, to put it another way, a1, a2 up to an are congruent modulo n to 0, 1, 2 up to n minus 1, taken in the same order. Okay, consider these 7 integers under modulo 7. You can get the value as 0, 1, 2, 3, 4, 5, 6 up to 0 n minus 1, 0 to 6 values. Okay, here we consider n as 7, then we can obtain the integers 0, n minus 1, 7 minus 1, you can get 6, then you can represent for this value 0, 1, 2, 3, 4, 5, 6. Here minus 12, add 14, 7 times 2, you can get 2, no? 2. For this one, add 7, you can get 3. 11 minus 7, you can get 4. 13 minus 7 times 2, 14, you can get 1. 22 minus 7 times 3, again you can get 1. This one, uh, 82 minus 77, no? What is the answer? 5, no? 5. Find the value of 91. You can get, I think you can get 6. So for these 7 numbers, you can get the residue as 2, 3, 1, 4, 5, 6. Only less than values for 7. Okay, for you can write this theorem. For arbitrary integers a and b, A congruence B modulo n under modulo n, if and only if A and B leave same non-negative remainder when divided by n. Okay, next you can write this theorem. Let n greater than 0 be fixed and a, b, c, d, e are arbitrary integers, then the following properties hold. A congruence A under modulo n. If A congruence B under modulo n, then we can write B congruence A under modulo A n. We can change A and B. Okay. If we consider A congruence B and B congruence C under modulo n, then we can write A congruent C. Using divisibility theory, we consider A divides B and B divides C. Using that, we obtain A divides C. No? Did you remember that? A divides C. If consider A congruence B under modulo n, we can add a same integer for both sides under modulo n. A plus C and B plus C. And we can multiply both sides by a same integer C. AC and BC. We can consider the same power for the congruence A power k, again congruence B power k. In this example, we consider 3 congruence 24 under modulo 7, then we can get 3 power 2 congruence 24 power 2 modulo 7. T to the power 2 congruence 2n to the power 2 under modulo 7 for this one. For this congruent, we can add a same integer 3 plus 2 and we add 2 to the left side, then we can add 2 to the right side. Here 5, 3 plus 2 you can get 5, 24 plus 2 you can get 26. 5 congruence 26 under modulo 7. Okay. You can multiply this congruence by a same integer. I will multiply both side by 3. 3 times 3 you can get 9. 24 times 3 you can write the answer under modulo 7. You can write count example for all. Okay. So for this one, you can 3 congruence 24 under modulo 7. You can change it as 24 congruence 3 under modulo 7. Okay. Okay, write down this example problem. Show that 41 divides 2 to the power 20 minus 1. Show that 41 divides 2 to the power 20 minus 1. No need to find the 2 to the power 20 first. For that, we can apply this property. 2 to the power 20 can be write 2 to the power 5 times 4. Then we consider 2 to the power 5. 2 to the power 5 equal 32. Here we should consider the n as 41. 32 minus 41, you can get 41. You can get minus 1, no? Minus 9. So we write minus 9 here. Under modulo 41. Then we consider the power of both side k. K equal 4. 2 to the power 5. Again power 4. Minus 9 power 4. Minus 9 power 4 can be write using the power 2. Then we know that 9 times 9, 81. We can get repeat value for 81, 81. 81 congruence minus 1 under modulo 41. 81 minus 41 times 2. Consider the multiplication of 41. Here you can get 82. Then you can get the answer as minus 1. Minus 1. That is the reason to include minus 1 here. Then we can include minus 1 here. Minus 1 times minus 1, you can get the answer 1. Then using this one, you can write 2 to the power 20 minus 1 minus 1 can divide by 41. We got the answer. Did you understand that? If not, I can explain it again. Please tell me. Okay. Okay, you can write the problem number 2. Okay, find the answer. I will give some times to do it. Okay. So please try to do it. Huh? If you have any doubts regarding the problem number 1, I can explain it again. So please tell me. Okay. Problem number 1 එකේ මොකක්ද කියන්නේ? අපිට ඕනේ 2 to the power 20 minus 1 කියන එකේනා 41 multiplication එකක් විදිහට ලියන්න පුළුවන් කියන එක පෙන්වන්න. ඒ කියන්නේ 41 divides 2 to the power 20 minus 1. නේද? අපිට උඩ දීලා තියෙන property එකේ ගන්න පුළුවන් A congruence B under modulo n. Using that, we can consider the powers of A and B. Okay. A power k congruence B power k under modulo n if A congruence B under modulo n. Using that, we can write this one. 2 to the power 20 can be write as 2 to the power 5 times 4. Is this correct? Did you understand this one? 20 කියන එක නා ලියන්න පුළුවන් 5 වරක් 4 කියලා. ඊට පස්සේ අපි කන්සිඩර් කරන්නේ 2 to the power 5 විතරයි. We know that when 2 to the power 5, we can get 32. 2 times 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Then we can get 32. Okay? And 32 වල දැන් අපි හොයන්න යන්නේ congruent 41 එක යටතේ value එක. එහෙනම් අපි කරන්න ඕනේ 32 ට 41 එකක් එකතු කරොත් එන්නේ තව ලොකු සංඛ්‍යාවක්නේ. හැම වෙලේම always මෙතන තියෙන්න ඕනේ මේ 41 ට වඩා අඩු value එක. Then we consider 32 minus 41. 32 minus 41, you can get minus 9. No? So here we include minus 9. Okay? Now we are going to consider the powers of these two, A and B. A and B. Now we are going to consider a to the power k. According to this example, k is 4. Okay? So we consider here 4. 2 to the power 5 we obtain as 9 minus 9. Then we write here minus 9. For this one we consider power 4. Okay? Then මෙතන ගත්ත 2 to the power 20. අපි දන්නවා minus 9 ගේ power 4 ලියන්න පුළුවන් මේ දෙන්නගේ multiplication එකක් විදිහට. දෙවරක් දෙක දෙක එකතු කරාම 4යි. එහෙනම් මෙහෙම ලියන්න පුළුවන්. හරිද? ඒක තමයි මම මෙතන ලියලා තියෙන්නේ. -9 multiply කරාම එන්නේ 81. positive value එකක්. ඒක තමයි මෙතන ලියලා තියෙන්නේ. දැන් අපි 41 ට වඩා ලොකු value එකක් තමයි මෙතන තියෙන්නේ. ඒ නිසා we have to subtract 81 by 41. 81 කියන එකේනා 41 ගේ අඩු කරනවා. ඒ කියන්නේ අඩු value එකක් තමයි මෙතන ලියන්න ඕනේ 41 ට වඩා. එහෙනම් 81 කියන එකේනාගෙන් 41 අඩු කරනවා. 41 අඩු කරාම මොකක්ද එන්නේ? 40 නේ. අපිට මෙතන 40 තියන්නත් පුළුවන්. ප්‍රශ්නයක් නැහැ. දැන් 40 තියෙනවා. මෙතනත් 40 එහෙනම්. ඊට පස්සේ අපිට පුළුවන්නේ මේ 40 ගෙන් ආයෙ 41 එකක් අඩු කරන්න. කැමති නම් එකතු කරන්නත් පුළුවන්. එකතු කරාම ආයෙත් එන්නේ 81. 81 ට තව එකක් මේ 41ක් එකතු කරන්නත් පුළුවන්. හැබැයි අපිට ලේසි කැල්කියුලේෂන් එකක් නෙන්න ඕනේ. අපිට මේ දෙන්න වැඩි කරන්න අමාරුයිනේ. එතකොට මම කරන්නේ 40ට අය -41 දානවා. එතකොට මෙතන -1 එනවා. 40න් අඩු කරනවා 41. මොකක්ද ආන්සර් එක? -1. ඒ -1 තමයි මෙතන ලියන්නේ. ඊට පස්සේ මෙතන -1. -1 මොකක්ද දෙන්නේ? +1 නේ. ඒක තමයි මෙතනට දාලා තියෙන්නේ. එහෙනම් මේ congruent එකෙන් ලියන්න පුළුවන් A congruent B under modulo n නම් A equal B plus n times k කියලානේ. එහෙනම් ලියනවා 2 to the power 20 minus A can be divided by 41. ඒක තමයි මේ අරන් තියෙන්නේ. දැන් තේරුණාද? Okay. Okay, anyone please tell me got the answer for the problem number 2? Anyone got the answer? No. Find the remainder obtained upon dividing the sum 1 factorial plus 2 factorial up to 100 factorial by 12. What is the answer? What is the remainder? You should be able to find it, okay? According to this example, you have to consider simple n as 12. You have to consider under modulo 12. No? We should divide the summation of 1 factorial, 2 factorial up to 100 factorials by 12. Think about how find the solutions. You should be able to get the answer. Anyone please tell me your answer? Anyone? Yes. One of you got the correct answer 9. Yes, one of you got the answer, correct answer 9. Now you can see the answer. So for the factorial one, we can get 1 under modulo 12. And for the factorial 2, 2. For the factorial 3, we can get 6. We can write here 6 under modulo 12. Factorial 4, we have to consider 1 times 2 times 3 times 4, 12, 24. You can get 4 factorial as 24. Under modulo 12, it is congruent to 0. No? So 0 we write here. 5 factorial, we can get here 24 times 5. 120. No? Again, you can get 0. Then this one 0, other terms will 0. Okay. Then we have to consider only first two terms, 1 plus 2, 3, 3 plus 6, you can get the remainder as 9. Okay. Okay, in these properties, we consider only addition, multiplication. If the congruence A, congruence B under modulo n, we can add some value to the both side and we can multiply multiply both side by a integer C. Okay, so we cannot divide both side by a integer. So here we define another theorem to divide integer, divide both side by a integer. Okay, so above properties explain only for addition, multiplication and to powers. This theorem explain how use the congruence using division. If A congruent CB under modulo n, then we can divide the both side by C, integer C. Then we have to change the modulo n by d. D is the greatest common device of C n. Okay. The above properties explain only for addition, multiplication and powers. This theorem explains how use the division for the congruence. If CA congruent CB under modulo n, then we can write A congruence B modulo under modulo n over D. D represent the greatest common device of C and N. Okay, C and N. We divide both side by integer C. For that, we have to consider first the greatest common device of C and N. After that, we have to write here mod N over D. Okay. For the above properties, we didn't write like this. We consider same mod N. We add integer for both side and we consider same mod. We multiply both side by C, we consider same mod. And when consider the power of both side integers, we consider same mod. For the division, we have to change the mod. If CA congruent CB under modulo n, if we divide these congruents by C, we have to change the modulo. N over D. Okay, D is the greatest common device of C and N. Okay, now after that you can write this corollary. If CA congruent CB under modulo n and GCD of Cn equal 1, then we can write A congruence B under modulo n. If D equal 1, you can write the same modulo mod n. After that, you can write the definition linear congruence. Please write it, okay?
Madam, your mic is muted.
Okay, you can do the problem number 4 as a homework. Okay. And the problem number 3, I think you got the answer. Here you can get the greatest common device as 6. Then using that, you can say this problem has incongruent solutions, 6 incongruent solutions under modulo 42. Here I have mentioned that all 6 solutions for this problem number 3. And problem number 4, you can do it as a homework. First of all, you have to find the greatest common divisor. Using that, you can identify the number of incongruent solutions. Okay, after that, you can find the linear Diophantine equation. By substituting t values, you can find all incongruent solutions. So try to do the problem number 4 as a homework. Okay, so okay, today we discuss how to solve linear Diophantine equation in 2 variables, no, 2 variables and 3 variables. In the linear Diophantine equation, you have to remember 2 formulas. By substituting A, B, and D, you can write the general solution for X and Y. Okay, so in the linear Diophantine equation in 2 and 3 variables, you have to remember 2 formulas. First, you have to find the greatest common divisor. After that, you can find the particular solution and variable t. Using that, you can write the general solution. And we start the chapter 3 and the theory of congruence. And here mentioned that the definition, I think you should understand what is the meaning of congruence under modulo some integers. Okay, so and we discuss some properties, 5 properties here. And for the division, we consider another theorem here. If CA congruent CB under modulo n, we can write like this. We have to divide the modulo n by d, greatest common divisor of C and n. And we did this example by considering this one. I think you can do the problem number 4. I will check this problem the next day. Sometimes I can do the lectures tomorrow. I will inform it. You can check the LMS. Okay. If not, we can do the next lecture the next week. Okay. I think today lectures understood for all. So if you have any doubts regarding the linear Diophantine equation and the chapter 3, the theory of congruence, you can ask me now. Okay, if not, I can stop the lecture. So thank you all for attending. I will inform about the tomorrow lecture. Okay, I will upload the Zoom link to the LMS. Thank you for all for attending for the lecture, and I try to understand all the concept in linear Diophantine equation and theory of congruence. Okay. will see the congruence problems and the linear Diophantine equation in two variables. Okay, so try to understand all things. Okay, thank you all.